In this part 5 of carbonyl compound, we are going to discuss about the identification of aldehyde, especially aldehyde, by tollens reagent and fehling solution. First of all, we have to remember that tollens reagent as well as fehling solution both can identify only aldehyde compound, that means the compound having CHO group, not ketone. First of all, tollens reagent. What is the meaning of tollens reagent? That is also a very vital question. Question may be asked, what do you mean? What is the chemical nature of tollens reagent? How it can be prepared? So it is ammoniacal silver nitrate. Ammoniacal silver nitrate, and the formula is given by AgNH3 2. This is the complex type of compound of silver and OH. So this is the tollens reagent chemical formula. Now how it can identify? Actually, whenever RCHO, whenever any aldehyde react with any tollens reagent, that means it will boil, heat will be given. Silver, that means silver is precipitated. It is grey precipitated, grey color, or silver mirror precipitated. Silver mirror effect will be there inside the test tube. So that's why another name of this reaction is silver mirror test. One prominent example I am giving over here says CH3CHO is given there. That means acetaldehyde is given along with tollens reagent silver. This is the tollens reagent is given over here. It is boiled. That means silver is precipitated out along with CH3COONH4 plus NH3 and H2O along with H2O. So this is the total reaction I have given over here. If we want to balance it, you have to write down 2 over here, this 2, and it will be 3 over here. Yeah. So this is the overall reaction. You have to remember that tollens reagent, this is the tollens reagent and this is the effect. After giving the tollens reagent, this is the effect, that means silver mirror precipitation will be there. Whenever it is aldehyde, whenever it is not aldehyde, that means ketone cannot respond this reaction, ketone cannot give this reaction. Thus we can distinguish aldehyde as well as ketone. So if the question is given, say acetaldehyde and acetone, how we can distinguish chemically? Oh, obviously we can use tollens reagent. It's very important. Now moving towards the fehling solution. First of all, again the same thing. What is the meaning of fehling solution? It is the 1:1 mixture of 1:1 means same volume, equal volume of fehlings A and fehlings B will be taken. Fehlings A equal actually copper sulfate solution and fehlings B is sodium potassium tartrate. Sodium potassium tartrate in NaOH. So this is the mixture of these two. This is the fehling solution. And second same thing, when case of fehling solution, what will be the effect? When case of fehling solution, whenever aldehyde is given, mind that here it is aliphatic aldehyde. Aromatic aldehyde cannot respond this reaction as well as ketone. So whenever it is given, so the effect will be like this. That means after giving this one, Cu2O, cuprous oxide, the precipitation of cuprous oxide will be there, reddish PPT will be there, RCOO minus. If you try to balance it, obviously it will be 2 here, it will be 5, whenever 2 it will be balance and it will be 5, then 1 2 it will be 3. Okay, fine. So overall, so it is a reddish brown PPT will be there. Whenever aliphatic, mind that aliphatic aldehyde is there, then only this type of response will be there. Whenever it is aromatic aldehyde, say benzaldehyde is given, benzaldehyde cannot give this reaction. So but thus fehling solution can distinguish among the aldehydes also. That means aliphatic aldehyde and aromatic aldehyde. As well as ketone also. If the ketone, the same question as I have given in case of this, that means acetaldehyde and acetone, how we can distinguish it? We can easily distinguish by using tollen reagent as well as fehling solution. Not only that, whenever acetaldehyde and benzaldehyde is given, how we can distinguish chemically? In that case, we cannot use tollen reagent. We have to use fehling solution only. Then only we can distinguish chemically. Okay. Now moving to the next part, that is Haloform reaction. Moving to the next part, that is Haloform reaction. What is Haloform reaction? A very important reaction it is. Haloform reaction means it is the preparation of haloform. Haloform means CHX3. That means X means halogen, halogen means chlorine, bromine, iodine. That means CHCl3 can be prepared, CHBr3 can be prepared, CHI3 can be prepared. So whenever it is CHCl3 it is chloroform, whenever CHBr3 it is bromoform, and whenever it is that means iodine, it is CHI3, that is called iodoform. In that case, particular in case of iodine, it is this haloform is known as iodoform test. So iodoform and haloform reaction both are identical, same thing, same reagents are required, that is halogen is required along with NaOH. NaOH is required, that means basic medium, alkaline medium is required, halogen is also required. That means depending on the requirement. If it is iodoform, if the question is given what is iodoform reaction, obviously in case of halogen we have to write down I2, that means iodine. Whenever it is specified as iodine, it is haloform is known as iodoform test. Most of the cases iodoform is mainly used. Why? Because in case of iodoform, that means CHI3 having a yellow PPT, that means visible change is there. If visible change is there, we can easily identify any organic compound, and like here this type of compound we can identify. But here main the condition, which type of compound can respond haloform reaction. Always we have to remember that the compound must have keto-methyl group. Keto-methyl group must be present there. Keto-methyl group means what? CH3C double bond O. That means this part must be present in the particular compound, then only it can respond the haloform reaction. Always we have to remember this is the main important part. Whenever this part is present, then only it can react. Otherwise, other type of compound can also respond. Which type of compound? Or the compound having this part. This part. So whenever the compound having this part also, it can also respond. How? Because after the oxidation it can convert, that means after the oxidation it can convert into this, because it is NaOH is there, so NaOH is, can oxidize this one to that. So then after that reaction can be happen. Now moving to the reaction. So this is a very important condition, we have to remember that. Moving towards the reaction, how the reaction is happen? Actually RCOCH3 in general formula I am giving over here. I am using the iodoform reaction only, that means iodine is given along with NaOH. So what will be the product in that case? CHI3 will be prepared, that means yellow PPT. Yellow PPT, we will get yellow PPT whenever this group is present, plus R, look at here, this is the R group, RCOO Na plus NaI plus I2H2. So whatever, so this is the main important product. We have to remember that depending on that we can identify the compound which having ketomethyl group. So this is also vital question. Also question may be asked from this part also. Some questions I am giving over here. Distinguish chemically. How we can distinguish chemically? What the difference between two compounds? First of all, if this compound is benzaldehyde is given, say benzaldehyde CHO, how we can distinguish? How we can identify? We can use which one? Tollens reagent. Mind that Tollens reagent can respond. That means grey PPT will be there or silver mirror PPT will be there. But we cannot use fehling solution. Fehling solution cannot be used. Iodoform test cannot be used. So obviously we have to use that with Tollens reagent it can respond. Secondly, if the question is given say CH3 COCH3, which type of compound can be used to identify acetone? This is acetone. Obviously we can use here Tollens reagent can be used. No, Tollens reagent cannot respond. This is ketone one. Fehling solution can be used. No, fehling solution cannot respond. Iodoform can be used. Yes, iodoform can be used because CH3CO part is there. So always we have to remember that this can be used here. Say this compound is given CH3CH2OH. How we can identify this chemically distinguish it? So obviously here we can remember, if we write down by this manner it will be much more clear to you. Say, look at here. So this group is present. As I mentioned in this case earlier, whenever this group is present, so this group is present. So iodoform is applicable for here. But Tollens reagent, no. Fehling solution, no. It is also no. Why? Because it is alcohol. Alcohol cannot respond this one. So Tollens reagent and fehling solution both are mild oxidizing agent. So it cannot oxidize this compound. So this is the thing we have to remember. So hope that it is clear to all of us. So we have to practice more and more, then only it will be much more clear to all of us.